Hi everyone, in this video we're going to discuss about how to build and run machine learning models trained with teachable machine. So we're gonna figure out whether it's recognizing objects, interpreting the body poses from videos, or classifying the text sentiment. So firstly we're gonna do object classification. So we are working with a model trained to distinguish between books and mugs. So these are the two objects which we'll be using in this part of the code. So we start by installing essential packages such as TensorFlow, which runs our model, and TensorFlow.js helps to load it, and Pillow handles images. NumPy helps it with math, and Matplotlib is for visual output. So we're gonna load the model, which is a pre-trained teachable machine model. It's coded in a format that includes both architecture as well as the weights. And then we're gonna assign labels. Here we have two labels. One is book and other one is mug. So we define these class labels, which are critical for interpreting predictions correctly. Next, we resize and normalize any text image, converting it into the input shape which our model expects, and then we run predictions, displaying the image with the predicted label and confidence, and we test it on a few sample images. So this is the confidence and the predicted label is mug, and for this also the confidence is 1 with predicted label as mug. For this, the confidence is slightly less and the predicted label is book, and so on. Next, moving on to more dynamic pose classification. So we're going to analyze body movements from the static images captured. So here we load the moonlight lighting, a lightweight pose detector that gives us 17 key points per person. So this function reads a pose image, runs MoveNet on it, and extracts a flat list of its values representing x and y coordinates and confidence score for all the key points. And then going on to group example images under labels. This becomes our dataset, and then we flatten all those key points and train a simple classifier using scikit-learn logistic regression. And then we test this model with new poses, and it tells us which pose the person is doing. So here we label it as, we have two labels. One is single hand raise, so and other one is both hands raised. So after the training the model with logistic regression, as said before, it's gonna predict. So in this image, the both hands were raised and it predicted correctly. In this, only one hand is raised and it predicted the correctly. And next, moving on to text classification. So let's jump into NLP. We classify short sentences as neutral or opinionated using Google's Universal Sentence Encoder. So the Universal Sentence Encoder converts a sentence into a 512 dimension vector capturing its meaning in numbers. So we define training data and convert the text tables into numeric form, and then we transform the text into vector embedding and then train another logistic regression model. With just 4 samples, the model achieves perfect accuracy, but remember this is just uh, a proof of concept. Since I have limited compute resources, I haven't trained it much. So, and finally we test the model on new sentences comparing the predicted sentiment with the expected labels. So this is the precision recall, FN score, and so on. So these are the results.